So our theory to determine the behavior of the spot exchange rate, as we said, is based on expectations by traders and on interest rate differentials. Let's focus on the second part, so the interest rate differentials. This is quite important because we have a lot of data and information about interest rate differentials across countries. So it's not 100% linear and clear what we mean by the interest rate in the economy. There are many interest rates in the economy. There's the interest rate on government bonds, there's the interest rate on corporate bonds, there's an implicit interest rate in the stock market, and so on and so forth. What we will use here is interest rate on government bonds, which is a market that is extremely liquid, for which we have a lot of data and a lot of traders. So for this market, we have information available on the term structure of the interest rate, which is just a description of the interest rate that governments are charged to borrow at several different maturities, at 1 month, 2 months, 6 months, 1 year, and so on and so forth. Clearly, we can use the information for the term structure of the interest rate to infer what both what the spot exchange rate should be, according to the formula that we see at page 26. But even more, even more importantly, we can use the information contained on the term structure of interest rate to infer something about the expectations of the market of where the spot exchange rate will move for each maturity of the term structure. If you flip your slides to page 27, you will see that with some simple algebra passages, we can derive a relationship between the expected exchange rate in the future minus the current exchange rate, which is expressed in the data, relative to the current exchange rate, so this will be a percent change, and on the right-hand side, the interest rate differential, which we can get just from the term structure. So suppose we have US government bonds paying 5% at 6 months, and British government bonds paying 2% at 6 months. That means if our model of exchange rate determination works, that the markets, the traders, are expecting a change in the exchange rate at 3 months of 2%. So you've seen how in a very straightforward way we can infer from the term structure of the interest rate what the expected change in exchange rate the traders in the market are expecting. So at slide 28 we see a concrete example of this type of inference. So we see in the graph a term structure for the domestic interest rate and for the foreign interest rate. And we see that this term structure is showing a gap that is widening. So at 3 months we have a certain differential between interest rates, which is 5%, and at 6 months we see that this differential grows to 10%. Using our formula, which is based on the idea that the uncovered interest rate parity holds, we will see that this directly translates into what traders expect is going to happen to the spot exchange rate. In particular, they expect that in 3 months, the spot exchange rate will grow by 5%, and in 10 months, it will grow by 10%. If we start from an exchange rate of 1.35, this will mean that the markets expect that the exchange rate in 3 months will be 1.417, and in 6 months it will be 1.485. Clearly, the traders can compare this information with the forward rate and then use this information to make investment decisions such as the one that we have described in slide 19, in which we said that if the forward is greater than the expected future exchange rate, we should sell forward and buy in the spot market in the future, and vice versa. If we expect that the forward rate is lower than the expected future exchange rate, then we should buy forward and sell in the spot market in the future.